In the following video, I will be solving a compound interest problem in which the principal is changing. So the exercise says like this. Janis opened a saving account on October 1st, 2014 with a deposit of $1,500. She added $3,000 on May 1st, 2016 and $2,500 on July 1st, 2019. How much is in her account on December 1st, 2021 if the deposit earns 6.8% compounded monthly? For solving this problem, we understand that there is a deposit at the beginning, so we are going to use the formula of future value. Remember, the formula of the future value is S equal the principal 1 plus I to the power n. We also have here the information of the interest. And we know that the interest is 6.8%. So the rate of interest is 6.8%. But this is not the I that appears in the formula. This is the periodic rate of interest. So this interest is annually. So we divide by 12. There are 12 periods because they said compounded monthly. So n equal 12. So the I that I'm going to use in the formula will be I equal 0.068, so that means 6.8% divided by 12, because every year we have 12 periods. So for getting a solution, so if we think in this timeline of the deposit, we think that at the beginning there is a deposit of 1,500. So on the 1st, 2014, there was a deposit of 1,500. But after that, on May 1st, 2016, there was another deposit of 3,000. And later, on July 1st of 2019, there was another deposit. And finally, the question is, how much will be here at the end on December 1st, 2021? So the first thing to do is to know how much will be in the first period with the first principal of 1,500. So as a step one, we are going to compute a future value of the first period between October 1st, 2014 and May 1st, 2016. So how much will be the future value of this? And this will be our first step in this problem, to compute the first future value or the future value in the first period of time between October 1st, 2014 to May 1st, 2016. I'm going to call this future value S1. So the first future value. So let's solve this. Of course, to compute this future value, we are going to use the formula of the future value. But in the formula of the future value, we have the principal, and we have the principal, 1,500. We need I, and we have I, that is 0.068 over 12, but we don't have n, the number of periods. How many compound periods are between October 1st, 2014 and May 1st, 2016. So we need to know how many compound periods, so we need to know the time between October 1st and May 1st of 2016. So for computing the time, what we're going to do is compute the time between October 1st, 2014 and the October 1st previous to this May 1st. Previous to May 1st, 2016 will be the October of the previous year. Yeah? So it will be October 1st, 2015. So I'm going to compute the time between October 1st, 2014 and October 1st, 2015. And later I'm going to count how many months between October 1st to May 1st of the next years. So, and of course, this will be very easy to notice that this was only 1 year. So if you don't notice, the only that you need to do is subtract. If you see that the date is the same, October 1st, of two different years, you just subtract the number of years. 2015 minus 2014 is 1. So it will be 1 year here. And then you need to count how many months between October 1st, 2015 and May 1st, 2016. So And you can count this using your finger. Yeah, this is October 1st, where you can count. November 1st is 1, December 1st is 2, January 1st is 3, etc. until you get until May 1st. You will notice that there are 7 months. So let's type here 7 months. So the period, the time between October 1st, 2014 and May 1st, 2016 is 1 year, 7 months. You can type this as a number. You can say 1, 7, 12 years. This 7, 12 refers to 7 months. So remember, a month is 1/12 of a year. So we have here then that we have 7 months, so we have 7 divided by 12. 1, 7 divided by 12 years. And if you want to know how many months, it will be these numbers multiplied by 12. If this was quarterly, then you multiply by 4. If this is semi-annually, you multiply by 2. In this case, it's monthly. So the time you multiply you multiply the time by 12, and you're going to get the number of periods, the number of months. So in this case, it will be n equal 1, 7 divided by 12, multiplied by 12. Of course, you can observe that 1 year is 12 months, plus 7 months is 19 months. So you don't need to do that. But just in case if you don't notice, you multiply the number of years multiplied by 12 to know how many months. If this multiplication can be done in a calculator, I'm going to do this in a calculator. I know the answer is 19. We know because it's 1 year, 12 months, 7 months, 12 plus 7, 19. But let's compute it. How to do it, just in case in another problem when it's going to be more difficult, maybe it's quarterly or semi-annually. So I'm going to use my calculator. So I open the calculator, and the key for using a mixed fraction like this, it will be this key that appears here, this A, B over C key. So this is the fraction key. So this is the one that I'm going to be. And I will be pressing keys here. And when I press the key, you are going to see the key that I press here beside me, okay? So in this case, it will be 1. So I press 1. And obviously, appears the 1 in the screen of the calculator. And it will be appearing here also, the key that I'm pressing. Then fractions. So the fractions, when you press this key, fractions appears in the screen of your calculator, these symbols. That means you're writing a fraction. Then the other number of the fraction is 7, so you type 7. And then again fractions, so over 12, you use fractions, press fraction and type 12, 1, 2. So you are going to see this number in your calculator, and I'm doing this just for you to know how to use it, or for you to remember how to use it. Then I'm going to multiply by 12. So multiply by 12. So if you do that and press the key equal, it will give you the answer. So I'm going to press here equal this, and that gives me that is 19. So n equal 19. So the number that I'm going to put here as a fraction here in the formula of future value, the n, it will be 19. So now that I have this, the only that I need to do is just make a substitution. P is 1500, I is 0.068 divided by 12, and this n is 19. So let's make a substitution and type it here. So it will be 1500, open bracket, 1 plus 0.068 divided by 12 to the power 19. And this is just using this formula. And then you can use whatever calculator to do that. I'm going to be using the Sharp calculator 500. So I get my calculator again. When I get the calculator, I type 1500, open bracket, 1 plus 0.068. There will be some calculators that need a multiplication sign here between the number and the bracket. But if you have this Sharp calculator, you don't need this. You can type the number and the bracket immediately. Let's do it. So these are the keys I'm going to use. I'm going to use this key, that is the key for power, the exponent key. So this key, I'm gonna be using the key for the brackets. These are the two keys that appear here over the multiplication and division signs. So these are gonna be the keys for the brackets, and I will be using obviously the plus and the division key that everybody knows where are these keys. So let's type this 1500, then open brackets. I'm going to open bracket, then 1 plus 0.068, 1 plus 0.068, and divide it. So I'm going to divide by 12. So I'm going to type 12 and cross the bracket. So I'm going to use this key here, cross bracket to the power. Then I'm going to use the exponent key, y to the x, it's the key, to the power 19. So I press 19, and then I'm going to use the key equal sign here. Obviously, when you finish to type everything, it will appear in the screen. The symbol that appears in the screen is different than the one that I'm using here. Yeah? This is y to the x, and here is just the symbol for the exponent. So to the power 19. And then I'm going to press the key, the key equal sign. So I press equal in the term 1670.01. You're going to see maybe more decimals in your calculator, but you should round it to 2 decimal. This is money. So round it to 2 decimal, you get this number. Okay, so this is what I have so far. We have computed this value here, the future value in the first period of time when the money was with this principal. Here we have the future value, and we're going to add something because there was a deposit that day. So this will be like my second step. So the future value that I have, that is 1670.01, to this future value, we have added an amount here that is 3,000. So she added 3,000 on May 1st, 2016. That will be my new principal, will be the future value I have. This is the green part here, 1670.01, plus the 3,000 that she added into the account on May 1st, 2016. So the new principal is for the next step of the problem, for the next period of time when the money was earning interest, it will be, let's call it P2, the second principal, 1670.01, the number that we got in the previous step, plus the 3,000 that she added that date. This will be 4,670.01. Again, this will be our present value, and we are going to compute another future value the day of the other deposit. So I want to know, before making the deposit, how much money was in the account. So with this present value, we are going to compute another future value. Let's call it the second future value. I'm going to compute S2. And obviously that day I will be adding the 2,500 that she deposited on July 1st. But let's compute first, as a second step, this future value of this second period. So for the second step, I'm going to use this as a principal. The interest is the same. There is no change of interest at that moment. And I will need to find the number of compounded periods. So I will need to find n. For computing the time, I'm going to compute the time between May 1st, 2016 until the May 1st that is previous to this July. What is the May 1st that is previous to this July? It will be May 1st, 2019. So until here, yeah? So how many years are between May 1st, 2016 to May 1st, 2019? The only that I need to do is just subtract the years. 2019 minus 2016 3 years. Let's type here 3 years. And then count how many months between May 1st, 2019 to July 1st, 2019. So from May 1st, 2019 to July 1st, 2016, there will be a few months. Yeah? It will be easy with your finger. After May 1st will be June 1st, 1, July 1st, 2. So 2. Another way to do it is noticing that July is the 7th month of the year. This is the 5th month of the years. 7 minus 5 equal 2. So, count with your fingers. You notice that will be 2 months. So what we have in time will be 3 years, 2 months. So 3, 2 over 12. Yeah? Remember, 1 over 12 of the years is a month. So in this case, there are 2 months, will be 2 over 12. So 2 over 12 years. So we have here the time. We multiply by 12 if you want. Some of you will notice that this is 36 months plus 2 months more, it will be 38. But if you don't notice, you can make a multiplication using your calculator, for example. 2 over 12 multiplied by 12. Because the compound periods are monthly. If the compound period were quarterly, you will need to multiply by 4, remember. Okay, multiply this times this, and the answer is 38. So use your calculator if you want, the way that we did it before in the step number 1. And then the 38 will be the number that appears in the exponent of the formula. So let's type the formula now. S is 4670.01. I is already know 0.068 over 12. And N is 38. Let's type everything here. So 4670.01 multiplied by 1 plus 0.068 over 12 to the power 38. Use your calculator in the same way we did it before. Yeah? Type the number, open bracket, so type the principal, open bracket, 1 plus 0.068 divided by 12, close bracket, raise it to the power 38. I get in my calculator, rounded to 2 decimal, $5788.58 in this case. Yeah? Okay, so, and this will be the future value that we have here in this, at the end of this period, in July 1st, 2019. I have 5788.58. This will be the future value. Obviously, I need to add that day the amount that was deposited that day, 2,500, and that will be the principal of the next period, and I will be making this in the third step. So let's compute. Compute the present value will be the amount that we have so far. So we are going to add this to this amount. We are going to add an amount. So the principal that day, let's call it the third principal, or P3, will be that plus the 2,500 that I deposited. And this gives me $8,288.58 that I'm going to use as a principal for the next period. So as a step 3, obviously, I will be finding this future value. That will be the future value that I'm looking for. So this will be, so as a step 3, what I'm going to do first, obviously, we need to find the time. So for computing the time, I need to know how long was the time between July 1st, 2019, and July 1st, previous to this December 1st. And previous to this December 1st, 2021 was July 1st, 2021. So between July 1st, 2019 to July 1st, 2021. 21 minus 19, it will be 2 years, and then count how many months between July 1st to December 1st of that year. December is month number 12. July is month number 7. 12 minus 7 is 5. So it will be 5 months here. Or you can count with your finger if you want. Count from the next month: August, September, October, November, and December. 5 months. Okay. And then the time will be 2 pi over 12. 2 pi over 12 years. Over 12 because we are counting months. And then multiply by 12 because this is monthly. Okay, so we multiply by 12 to know how many compound periods. So it will be 2 pi over 12 multiplied by 12. If you do that, the answer is 29. Obviously, you can notice that in 2 years, there are 24 months, plus 5 months more, it will be 29. Okay, now that you have this number, you can use now the formula again and to compute the future value. And this will be actually the future value on December 1st, 2021. That is the question. The question is how much is in her account on December 1st, 2021. So this will be the answer of the problem. So let's do it. S equal A288.58, that was the principal. 29 is now N, and we have the same interest. Use your calculator as the way we did it before, and notice that the answer is 9,764.45. This is the amount that she's going to have that day in her account. So as an answer, so I'm going to type here that the future value is 9,764.45. And now we can answer that Janis has 9,764.45 in her saving account on December 1st, 2021. And with that, I finish this problem. I hope you have found it useful. Thank you.